Okay, good morning, everyone. Thank you for this opportunity. Here we would like to present our paper research. First of all, let me introduce ourselves as the authors. First is Fauzi, Leilan, and second is Tania, Revina, Yasin, and also me, Darma, Hutajulu. Here, the title of our paper research is emission dispersion modeling using AERMOD on GT 1.3 PLTGU Muara Karang in evaluate combustor upgrade effect. Okay, the outline of this presentation today will be consist first introductions, and second is methodology, the third is result and discussions, and fourth is conclusions. We will go into the introductions. The reasons why we conduct this study consists of first, environmental crisis. The population growth and increasing of the human activity contribute the environmental crisis. So the sustainable of development depend on the human awareness to protect the earth. And the second is efficiency upgrading of the gas turbine 1.3. Gas turbine 1.3 has been operated in 1992 and being upgraded in 2016 for combustor line to increase the efficiency of performance and productions. And the third is emission dispersion study. In here, we want to know the dispersions effect after the machine has been upgraded, also the emission concentrations from the generation activity. And here we can see this is the location where study being conducted, especially going to the gas turbine 1.3 on the red circle. And this gas turbine has capacity 105 megawatts. Okay, we are going to the methodology. In the sections, there are three stages. The first is emission data from combustion modeling, pre and post upgraded by use computational fluid dynamic software. And the second is meteorological data analysis by use AERMOD software. And the last is emission dispersion by use AERMOD software. We are going to the first stage. These results use computational fluid dynamics. And here, the software is usable tools for predicting the temperature, also the flow. And in this case, the process of CFD simulation is divided into the 4 phases. First is drawing geometric. We're drawing the geometric and establishing mesh, configuring the model, and the post-processing. And beside that, there are 4 variables will be imputed also, consisting of air flow rate, fuel flow rate, inlet air temperature, and the last is inlet fuel temperature. And after we run the simulations, the result will be consist of temperature and emission value, and we will compare that results. And the second is the AERMOD. We use this software to develop the meteorological data, and the data will be consist first is cloud cover, temperature, humidity, barometric, wind directions, wind speed, mixing height, precipitation, and the last is solar radiation. And the last stage will be emission dispersion model. We're using the Gaussian plume equation. You can see in here the formula of Gaussian plume, and AERMOD software will be run by input several data such like NOx and CO2 maximum emission rate that we got from the CFD simulation. The second is coordinate boundaries and the grid of study area. The third is meteorological data that has been treated in AERMOD. And the last is elevation data from AERMOD software. And all those data will be run into the AERMOD. And the output will be isoplet imaging of the emission dispersion of the study area. And the result and discussion will be explained by my partner, Ibu Tania, Revina, Yasin.
Thank you, Darma. Okay, now I would like to explain about the result. And first, you can see this is the combustion simulation using GFD for the pre-upgrade condition and post-upgrade condition. And we can see for the major emission, the mole fraction between pre-upgrade and post-upgrade is almost similar. And we can say that the combustion process at pre-upgrade and post-upgrade is nearly perfect. We can see from the CO parameter that the concentration is 0%. At the table below, we can see the pollutant. We also use the simulation to determine the concentration of NOx. We can see that at the post-extendor, the NOx concentration is higher, and also the emission velocity also higher at post-extender. It is because at the post-extender, the temperature at outlet of the combustion is higher than when we doesn't apply the upgrade. Next. This is the wind rows that we get from the meteorological data. The prevailing wind is from southwest with average speed is 5.14 meters per second. Maximum speed is reaching 11.8 meters per second, and minimum speed is lower than 1.45. And the frequency of the occurrence of calm wind or wind speed below 1.45 meters per second and reaches 0.4%. And the highest frequency of this wind speed shows the wind speed in the range of 5.14 meters per second at 35%. Next, after we do the CFD modeling and also meteorological analytical data, we will do the emission dispersion modeling. And this is the CO emission dispersion modeling at initial environment condition and current environmental condition. We can see at the initial condition, the dispersion of emission is form a circle around the unit, but at the current environmental condition, the emission dispersion is go further to the right picture, or we can call it is at the east side of the plant. And the concentration, maximum concentration at post-extender in initial environment state and current state is lower than pre-extender. Next, we can see the NOx emission dispersion modeling. The concentration at post-extender at initial state and current state is higher than pre-extender. As I described before, the NOx is higher because the temperature at the combustion outlet is higher. So it forms more NOx in the emission. And in summary, we can say that, next, we can say that GT 1.3 extender combustor upgrade produce lower CO emission and show the result of perfect burning process. NOx emission, which is generated after upgrading, is increased to almost 14.5% with a value of 5.5 ppm if compared before upgrading, which is 4.5 ppm. The changes in environment around the study area also change the location points with the highest pollutant concentration. Initial environmental baseline, the highest pollutant concentration, fell in the Pantai Indah Kapuk area, or we can say the west side of the generating unit. However, the current conditions, the highest pollutant concentration fell in the Muara Baru area, or we can say at the east side of the generating unit. And thank you. That's all that we can provide for you today. Thank you for your attention.